This video will cover monopolies. We'll define a monopoly as a single producer of a good or service with no close substitutes. Monopolies have pricing power, and that's the key to a lot of the analysis that's going to be forthcoming. We'll discuss how and why monopolies form and continue to exist. We'll discuss monopoly profitability. We'll look at quantity, which is again determined by margins. Marginal revenue equal marginal cost, and we'll compute profits based on average total cost and prices. We'll compare and contrast perfect competition and monopoly pretty much all along the way. It's pretty much natural to do that. We'll examine societal aspects of monopoly, consumer surplus, producer surplus, deadweight loss, and then we'll discuss price discrimination. So we start off talking about why and how monopolies come about. And the short answer is they come about through barriers to entry. Monopolies will have pricing power, as we'll see. They will earn profits, but competition can't come in and steal those profits because of the barriers of entry. Now, the longer story is there's a list of items that I'm going to cover. These items are not mutually exclusive in the reasons for why and how monopolies develop. The first item I'm going to cover is technological advantage. In the late 1990s, for example, Microsoft bundled its operating system with Internet Explorer. So if you rewind back to then, and even to a large extent today, on PCs, Windows was the dominant operating system. And so Microsoft had this dominant position. And then when the Internet came along, it bundled its operating system with Internet Explorer, which was a browser at the time. So people were pretty much locked into Microsoft Windows. There wasn't really a good alternative. And then, when Microsoft bundled it with Internet Explorer, that meant that other companies that were trying to develop internet browser systems really didn't have access. They were barred from the market, so to speak. There was substantial barriers to entry. Another type of barrier to entry is there's a control of an input or possibly a natural resource. For example, De Beers Diamond Group, they controlled most of the diamonds output, and because they own diamond mines, for example, and so that comes about naturally. There's also what we literally call natural monopolies, and that can come about through specialization. Strong specialization effects continue as Q increases, quantity of output increases. Also, we could have increasing returns to scale. And increasing returns to scale, remember, could look like this. We have dollars for costs on the x-axis. We have quantity. And we could have an average total cost curve that keeps coming down like this, okay? And that would come about through increasing returns to scale. We don't have this like we normally see. There's no U-shaped average total cost curve. Examples of this would be Bell Telephone Company when it first started. You set up the telephone poles, you set up the wiring system. And once you have a region covered with your telephone wires and your telephones, it's hard for another company to break in. It almost doesn't make sense. Also, railroads are another example of the situation. You lay a railroad down, you basically have a monopoly. It doesn't make sense for another company to kind of come in and set down another set of tracks. The concept of network externalities is another source of monopolies. So the value of a product or service can increase with use of a customer base. This happened with the telephone. For example, if you're the only owner of a telephone, what's the value of that? It's not worth anything because you can't call anybody. The same thing with fax machines. Fax machines are pretty old-fashioned, but they kind of work like a telephone in a sense. Facebook, a more current example. I mean, if nobody else was on Facebook, it really wouldn't have much value to you. It turns out that the companies that get their foot in the door first, and look, that's a telephone company. That even could be a railroad in a sense. That could be fax machines, and it could be Facebook. It's hard to get people to switch to a new product once you've got them hooked into an initial network. And so this is where a lot of businesses, in order to try when they develop a product, they often give it away free to get people in there initially, because once they get people hooked into their network, their technological systems, people tend not to leave. And so it makes sense for them to want to give their product away, increase the number of people using the product so that network externality builds up. The fifth reason for how and why monopolies exist is sometimes they're government sanctioned. Patents, for example, especially on drugs, are important, and other inventions. It gives the patent holder, either depends on the country, 16 to 20 years monopoly rights, basically, to produce and sell a good. And then there's copyright agreements on documents and books. So now let's move over to pen and paper and let's analyze monopoly using our cost structure concepts. And then what we'll do is we'll not only look at apply our cost structure concepts, we'll compare and contrast the monopolies along to perfect competition along the way. Let's start off our analysis by looking at the pricing power that a monopoly has. So we have quantity, we have price, and a monopoly has a downward sloping demand curve. That's the demand curve faced by the firm and the industry, because the monopoly is the industry. Now, if you remember, when you have a downward sloping demand curve, we also have a downward sloping marginal revenue curve. And that marginal revenue curve has twice the slope. It's a negative slope. It has twice the slope as the demand curve. And we can prove that for a second. So P, right, price equals A minus BQ. That's just the formula for this demand line right here. Okay, so in quantity 0, this would be A, this area here, and then the slope would be minus B, and then Q, output. So then what we do is we look, okay, price equals that, total revenue equals P times Q, price times quantity. Substitute this price in, A minus BQ times Q equals AQ minus BQ squared. Now let's look at the change in total revenue for a change in quantity. Okay, that's marginal revenue. How total revenue changes with respect to a change in quantity, and that will equal A minus 2BQ. Now don't worry about how I get this math. Basically, look, the slope is twice. So you originally had this slope for the demand curve right here, B. Now it's 2B. So this slope is twice as much. It eventually, the marginal revenue curve can actually go negative. And if you recall, we can plot the total revenue here this way. So when your marginal revenue hits 0, your total revenue is maxing out and coming down. So remember, if you sell nothing, 0 quantity, 0 price, you're here. And there's a point where, and I'm not quite drawing this up to scale, but the demand curve comes down and eventually hits the x-axis. And so you got the price so low, but basically the price is 0 here, right? Because you come down, the price is 0, and you're selling a whole lot, but your price is 0, then you're not going to have any total revenue. Somewhere there's a flat spot here where your total revenue, at first it's positive, it's creeping up, remember? As quantity goes out this way, we have a price effect and a quantity effect. And early on, the quantity effect, this area, is much larger than the price effect. From the drop in price, increases quantity, so Q effect dominates. And then eventually things even out, and when you get to this side, you get the price effect is way larger than the quantity effect. This quantity effect is small, so you have price effect dominates. And you're on this side. Now, let's contrast that for 1 second with perfect competition. With perfect competition, we had a perfectly elastic demand curve, right? Price equaled marginal revenue. They were both the same line. And so when we plot this total revenue curve, basically there's zero total revenue because you're right here, there's zero quantities, right? And then starting at unit 1, you basically have a total revenue curve that just accumulates. So when you sell 1 unit at a price, you would have this total revenue or this total revenue. So you'd have a straight line here. Okay, so now that we have established the pricing power of a monopoly, that monopolies have pricing power because they face a downward sloping demand curve and they can determine price, they can raise price and reduce output, which is an important component of what we're showing here. They can raise price and reduce output. Let's look at a monopoly's profitability. Let's start off. So let's look at profitability of a monopoly. Actually, I should put dollar signs here. Here's the demand curve. Here's the marginal revenue curve. Let's put a Nike swoosh in so we get a little effects of specialization. And then let's compare for a second to what we said when we looked at perfect competition. We said marginal cost equals marginal revenue. That's where the firm should produce. That holds true with a monopoly. Let's look at it a little more carefully here to make sure we get our marginal analysis down right. Recall, look, if this is the demand curve, and the demand curve is downward sloping, which means every time the monopoly increases quantity, it has to drop price a little bit. So that means the marginal revenue is going to come down. So at this number of units, Q units here, right? This is the marginal revenue. That's the marginal benefit from the sale. And then here's the marginal cost down here. And so this is the extra you're getting. The marginal revenue is greater than marginal cost. And then if you sell another unit, well, it's hard to tell whether or not, given the way it's drawn, whether or not you got more benefit as the difference between here. You're getting that specialization effect. Now, if it was a straight line and marginal cost looked like this without the swoosh, then for sure you'd be shrinking. Each unit you went out to the right, your marginal revenue minus your marginal cost would shrink down to a point. Here you're getting the effects of specialization coming on here, but eventually look what happens. You sell more units, the difference is smaller. And then eventually when you get to this point, the difference is zero. And if you sell one more unit, your marginal cost will be greater than your marginal benefit, which means your profit is actually shrinking. So here your profit's accumulating. It's accumulating. It's accumulating at a slower rate when you get over here. But here it eventually goes negative. So you don't want to produce to the right of this marginal cost, marginal revenue curve. So that holds with the monopoly also. Now, what we want to do is look at, get my marker out here, where exactly is the price going to be? Well, if this is the magic quantity, so to speak, we're going to come up and over, and this is going to be the price of a monopoly. This will be Q, we'll call it Q star, and that'll be the price, the optimal price and quantity right here. To determine profitability, we're not there yet. And the reason we're not there is because we don't know where's the average total cost curve. We know the average total cost curve is U-shaped, and it's going to cross, right? It's going to cross at the bottom, will cross at this marginal cost curve. And so let's just shove one in here for the moment, put one in. And let's say, okay, here's average total cost curve. And that's our average total cost curve. To determine profitability, we need, remember, profits equal price minus average total cost times Q. So you want to maximize this difference, this price minus average total costs. And so, well, look at here. Here's price. Here's average total cost times the quantity. And here you have the profits that are established by a monopolistic firm. If the average total cost curve was up here, it wouldn't make any sense for the monopoly to produce because its cost would be greater than the price. So that wouldn't make sense for it to be in that market. And if its average total cost curve was down lower, it would be the same analysis. Right here is where you determine quantity, and then wherever the difference between the new red line and the black line, put another one up, put it here. Here's an ATC. So the profit would be even better here. The profit would be this difference between price and average total cost, and here would be your total profit. So before we leave this graph, it's getting a little messy. Let's compare it for a second to perfect competition. With perfect competition, there are zero economic profits. This has to be zero, which means this would be right here. Average total cost equals the price is where a perfectly competitive firm would behave. So notice what happens here. So we have a quantity under perfect competition, quantity under monopoly, and you can see that monopolies restrict output compared to, and this is the important case. This is the benchmark case, perfect competition. It restricts output compared to perfect competition, and in doing so, it moves up this demand curve and takes advantage of the situation and earns a profit. Earns a profit that, because of barriers of entry, other firms can't come along and steal. Now, I want to analyze the welfare effects, and I want to do it with the Nike Swoosh marginal cost curve. Now, granted, this is a little sloppy. So let's look at a slightly easier example, less realistic, but it's cleaner from an analytical point of view. So here we have a market or industry. It's not a firm, and the reason why it's not a firm, because I'm going to compare perfect competition monopoly, and with perfect competition, you don't have individual firms don't face a downward sloping demand curve. So this is a market or industry. Now, here's the setup. Again, a downward sloping demand curve, marginal revenue sloping down. Here's the simplifying assumption that marginal cost equals average total cost. And keep in mind when that happens, there's no specialization, so there's no downward shift on the average, on the marginal cost curve. There's no diminishing marginal returns, so there's no upward swoosh in the marginal cost curve and the ATC. And there's no fixed costs, so there's no spreading effects there. So it's just a simplifying assumption. And the point is we want to look at the welfare effects here. And what I mean by welfare effects is consumer and producer surplus and the total of consumer and producer surplus. So let's first look at what happens when we're in perfect competition. And we're in perfect competition, price equals average total cost. There's no profits, and that happens to be at the same point where price equals marginal cost. When we're in that situation, there is welfare effects. People are willing to pay these prices where my pen is going, right? But the market price is right here. The price is the market price for perfect competition. This wedge represents consumer surplus, and there is no producer surplus. From a consumer's perspective, this is a nice market in that people are willing to pay all along here, but they're getting the price. They're actually paying a price here, so they're gaining in terms of benefit from these transactions happening. Now, let's look what happens when we're faced with a monopoly, and a monopoly sets marginal revenue equals the marginal cost, and we're right here. And quantity is QM for monopoly. Come up, and we got price for the monopoly. And what we have here is, first off, there are no transactions here. So there's the reduction in the amount of output compared to the benchmark perfect competition. There's a reduction in output, and the price is higher, so the monopoly has moved up the demand curve here. But what's interesting is, look, now here's the price that people pay with a monopoly. Here's the price that people are willing to pay. This will be consumer surplus right here. The blue here will be producer surplus because the monopoly is getting this price and has a marginal cost and is willing to supply at these prices. So this is producer surplus here. And what we see is we end up with a deadweight loss. with a monopoly. These are transactions that never happen. Under perfect competition, these would be beneficial transactions, and these are all lost. And so this is welfare or society's benefit that's lost, basically, from having a monopoly. So what happened in total? We have a deadweight loss, which is a loss of consumer surplus, because this was all consumer surplus with perfect competition. And look, remember, when we looked at perfect competition maximized consumer and producer surplus. And so this would be the most efficient point from society's perspective. Now you've put in a monopoly into the situation, flip it into a monopoly situation, quantity is reduced, price is higher, there's a deadweight loss, which is all loss in consumption, in consumer surplus, and now producers gain a bit. So here's their producer surplus. They gain that, which we just didn't have under the perfect competition in this scenario. And then consumer surplus is obviously shrank down. So with monopoly, you can see, obviously, that monopolies benefit from their situation and consumers lose out. Now, let's move on and I want to make a quick and subtle point about monopolies. And so here I got another nice setup. And the point that I want to make here is that this is a very subtle point. You would never know it unless a textbook flagged it, or a professor in a video or somewhere, somebody would actually bring it to your attention. You can read chapters and chapters on this and not realize that a monopoly has no supply curve as we know it. I like to say it has a supply point, an optimal supply point. And here I've marked it in blue. It's where marginal cost equals marginal revenue. That's the optimal point. And the monopoly, if it does produce here, this is its QM, quantity for the monopoly. It's an optimal point. The monopoly could choose a quantity that's much, much less, move in this direction. It wouldn't be optimal, but they could choose a quantity that would end up here, or they could increase quantity and move down here. That would not be optimal. This is the optimal point, as we've discussed. One of the reasons why there is no supply curve here is, think about how we approached it when we looked at perfect competition and we traced out a supply curve which was equal to the marginal cost curve, if you recall. And the reason for that is, and I even have one of the slides that I was using, one of the pieces of paper output that I worked on to show you, back in perfect competition, we said, look, what happens if in perfect competition the price is $2 or some other price, and we're under this scenario, we were just literally given a price because the price is determined by the market. And we're saying, given a price level, where would the firm produce? And we traced out the supply curve, which is equal to the marginal cost curve. The situation doesn't happen. It doesn't happen here the same way, because the monopoly determines the price based on the quantity. So it picks a quantity, then determines, and from that quantity picks the price out. So the point is, there is a monopoly supply point, an optimal supply point. There is no monopoly supply curve. And you'll see the same thing later on when we get to a monopolistic competition. Because of this control over price that monopoly has, and even monopolistically competitive markets, that there is no supply curve. It's a point. Now let's move on to a really interesting area called price discrimination. So in this analysis, I'm going to take advantage of the concept of a flat marginal cost curve, simplify things. We have a downward sloping demand curve that the monopolist faced. I'm going to ignore the marginal revenue curve. It just muddies up the water in this analysis. We don't need it. And I'm going to ask a question now that you may not have thought of before. And the question is this: why can't a monopoly, since it has power, pricing power, why can't it charge 2 prices? Why can't it charge 3 prices? And what do I mean by that, 2 prices? Well, there are segments of the population, consumers, that have different demands and different willingnesses to pay for a particular good. And I'm thinking here, for example, I know that there are people very willing to pay a high price for a book that initially comes out. First comes out by a particular author. There are people that will jump on that book. They'll pay a high price. And there's people like me that will say, well, I'm not that anxious. I'm not willing to pay that high price. I can wait. And eventually the price comes down. And then not only does it come down, but if you wait long enough before the next edition comes out, the next book that the author produces, the price may come down even further. Video games work the same way. There are people that are very willing to pay a high price. They want that video game as soon as it comes out. In fact, they'll wait in line for it. And they'll pay that high price. There's people that will wait for it. And then there's people that won't pay anything and won't pay it much for it until right before the next version comes out. The next edition comes out, and the price will be even lower. There's examples all over the world about this type of concept. Even the airline industry, for example, they take a look at when people book their flights, when they're likely to be staying over on a weekend or not, and how soon, how early do they book their flight? Is it close to the actual takeoff? Well, it turns out the airlines take this information and they can process whether or not you predict whether or not you are a business traveler versus a leisure traveler. And so they know business travelers will pay more. It's often paid by the firm and not by the individual. And so if you book your flight right before the flight takes off, you're probably going to pay a higher price. If you're coming on your round trip back to your destination is on a Friday, well, that's likely to signal you're a business person because you don't want to stay out of town over the weekend. So all these things provide signals to producers that of a different willingness to pay. And so what we want to do is model that here and see how the monopolist takes advantage of it. So let's look at it here. Let's see here. Let's assume there's a high price. And we'll call it PH for a high price. And this is quantity high. And here are the sales to high-priced people with a very high willingness to pay. This will be consumer surplus here because this is the price being charged. This will be consumer surplus. This will be producer surplus. But I don't want to really get it at surplus here. This square right here will be profits. That's what I want to get at. Right here. So that's the profits associated with these high-priced people. Now, there's people who will wait a bit, and they'll pay a lower price. I'll call it PM for middle, and that it's connected with QM. And so here's the sales for the middle-priced people. And the profits for the monopoly will be here for these middle-priced people. Then there could be, imagine, PL for low. They're the people who want to wait till right before the next edition comes out and next version comes out, next book. And we'll call that QL, and here's the profits associated with those. Now notice what's happened. The monopoly now has grabbed this profit for the high-end people, this profit for the middle people, and this profit here for the low-end people. Had the monopolist charged one price, they wouldn't have been able to scrape up and grab all these profits. Now, imagine what would happen if a monopolist had perfect information about consumers who buy their product. This is like big data, collecting big data off the internet to see exactly what type of consumption and willingness people are willing to pay based on their behavior. But imagine that a monopolist could get this perfect information from big data, and they could charge an infinite number of prices. So if they could charge an infinite number of prices, they'd be charging a high price here, collecting all this profit, and they'd have a price. They'd be able to gather and profit the entire way through. This entire wedge right here would be profit to the monopolist. That's a monopolist's dream, to be able to segment various customers based on their willingness and charge a high price, an appropriate price for each one of them based on their willingness to pay quite interesting, and that's an underlying motivation for big data. Well, you kind of already know that there are firms collecting big data and they want to profit from it, but it's nice to be able to work it into a model like a monopoly. It's important to realize for this analysis to work that not only does the monopolist have to have perfect information about consumers, but the monopolist needs to be able to segment the market carefully. And the reason for segmenting the market is consumers are savvy with this. They know what's going on. They will try to arbitrage the situation, somehow disguise their willingness to pay, so they try to get a lower price. And businesses realize this also. So the type of segmentation that you see out in the market is, for example, volume discounts. Well, volume discount, you're willing to buy a lot of goods and you have a lower price on it. You may have a lower willingness to pay, but you're buying high volume. Early bird specials, for example. So dinners maybe go from 4 to 6 o'clock. That's trying to get people into the business early. You can separate those people by time, just like you can separate people by how much the volume they want to buy. Then you can separate people in terms of, just evaluating them in terms of senior citizens or not. So senior citizens often are on fixed income, and so you'll see senior citizen discounts, and so that market can get segmented. So as you can see, this is a very rich area in behavioral economics.